So I thought I should make some explanatory comments, put it in context. Consumers living in the more affluent parts of the world are showing an increasing preference for meat and dairy products produced under grazing rather than in confinement, for a whole range of reasons. Just as one example, the Irish dairy industry just last year announced plans to increase its dairy production by 50% over the next 10 years, and all through increased grazing intensity rather than housed. Perhaps ironically, they see a huge export potential for this added value end of the market in the USA. So you have been warned, Mr. Trump. In New Zealand's case, our relatively benign climate has allowed us to stay with grazing all the way through. And for a number of reasons, over the last 20 years, the number of dairy cows in New Zealand has increased quite dramatically, and milk production even more so, which has occurred through a combination of within farm intensification and the conversion of land from other uses. And over 98% of the cows in New Zealand are grazed year round, and typically only 10% of their feed intake is coming from bought-in grain and other feeds. And there's been a big change in the typical pastures. We've gone away to a large extent in dairying from the traditional perennial ryegrass white clover mix, requiring little or no nitrogen, to higher producing ryegrasses, which have a much higher fertiliser requirement and have to be resown every so often, 3 or 4 years. So that's led to a much increased application of nitrogen per hectare. This map just shows a part of the South Island of New Zealand. We have a North and a South Island. That keeps it sort of simple and logical. And all those little triangles represent wells which are used for on-farm irrigation and drinking water in this Canterbury area. And the ones that are in red, which particularly in this part there, ones that are showing a steady increase, and in many cases already well over the 10 parts per million nitrate N limit. And there is a very, very strong link between that and the intensification of dairying, particularly with irrigation development in that area. So there's no doubt, I think, at any level, whether it's government or scientific or farming, that the increase has come from the intensification of dairy farming. I've just realised that we're running off. I gave an updated version. We're running off the old one. I don't know how long it would take to change, but I can stay with this one. They did tell me they had removed the old one, but not so. They're both on here, but I had been told that the old one had been removed. Yes. So that's fortuitous, because very little change up till now. So what is the problem? Well, there's one of my fellow Kiwis mentioned yesterday, the problem is this simply here: when the cow urinates, which contains increasingly more of the nitrogen in the feed as the nitrogen in the forage increases, you're getting an application rate in that small area of typically 40 centimetres diameter of 600 to 1,000 or a tonne of nitrogen per hectare, which is massively beyond the ability of the pasture to recover. So another 20 to 40% is lost to nitrate leaching. And therefore, inevitably, is going to end up in a water body of some sort, whether it's a river, lake, or groundwater reservoir. And this, as I say, is a reason for the increase in nitrate in groundwater that we saw before. So this, if you like, quite attractive mosaic of the urine patches on a grazed pasture that you see, that's probably about 2 to 3 weeks after grazing, showing the very distinct responses to the urine. Once you can see that, it's too late to do anything about it because all the nitrogen from the urine is now in the form of nitrate, and it's just a race in time against how much of that nitrate is going to be leached into the groundwater or taken up by the pasture. So there's been a lot of ways, I'm not going to run through all of this, but just to give you some idea that we have been looking at a variety of options because of this nitrate problem, including even going into cow housing, of course, but I think what rules it out in New Zealand is the high capital and running costs, and what's becoming an enormously important factor internationally, though it doesn't seem to be really on the radar at a state level in the United States yet, is the massively increased ammonia losses you get from a housed cattle system or any housing of animals. And ammonia is now being viewed far more seriously in terms of its what it does in the atmosphere, particularly in bringing about the fine particles that are so damaging to the respiration system. So for a variety of reasons, that's not going to happen in New Zealand, and with low international milk prices, that makes it even more certain. Just going on to the next one, certainly have standoff pads so that the cows aren't on the pastures as long, and combined with bringing cut and carry crops into these pads for feeding is going to be part of the solution. We're even looking at things like putting salt in the drinking water, but I think there's some to make them thirsty, so they drink more, so that the more urine, so the nitrogen in the urine is more diluted, but there's obviously some potential ethics issues there. So none of these solutions individually or even collectively are going to be capable of bringing about the reductions in nitrate that are required. And seriously, at this right where we are today, a significant proportion of New Zealand dairying is looking at having to be converted back to some other farm use unless a practical solution is found, and one which achieves the required reductions in nitrate and produces tangible economic benefits for the farmer. You put those two together, then you can do something. So when I've got a scientific background myself, but and in the fertiliser industry, but with a new venture with a mechatronics engineer, we were looking at the problem together and decided that really we needed to do something about, well, firstly finding the urine patches, and then doing something that's about this very rapid first step, the conversion of the urine urea. 80 or 90% of the nitrogen in urea and urine is in the form of urea in the case of cattle. It's going through to ammonium, some of which gets volatilized as ammonia very, very quickly, and then a bit more slowly through to nitrate, and then it's just a race between how much gets recovered versus how much gets leached or lost in other ways. So we came up with a solution we've called Spiky. There's a reason for that, but as I said, what Spiky does, which I'll show you in a second, is a tow-behind device, or could be mounted on a track or trailer, which is actually measuring the electrical conductivity in the near surface of the soil. And this is a pre-production model. The production models, which are literally going into production now as we speak, have got wings of 3 metre wide wings on either side to allow it to get through gateways. So the centre module is 3 metres wide, total 9. And you might just be able to pick up there, that's an array of spike metal wheels which are actually acting as electrodes and are measuring the electrical conductivity. It's a little bit more complicated than that, but in the soil, and we get, fortunately, if this gets towed around a paddock after cows have left it, every day or two is okay. Sorry. This is just showing the electrical conductivity, the data from the processor, and the little boxes at the bottom, these blue ones, are just to show you where a urine patch was deliberately, or put manually so we knew where it was, and these are the spikes in electrical conductivity measured by the spike wheels. The spikes are just to cut through any residue of grass, and it's just never misses. You get a few false positives, but all the ones we investigated dung pats or cow pats, and we can remove those or include them as is required for a particular situation. So, and you remember the previous diagram, so what we've done in effect is giving a much longer time for the conversion of the urine to ammonium by using a urease inhibitor. I'll say a little bit more about that. And that in turn increases this period here. So because of the urease inhibitor there, that allows the urea in the urine to spread out laterally. Gives you a much bigger patch, 70% on average is the running average, and you get much more nitrogen uptake, which means less nitrate leaching. So strangely enough, it works very well. So I won't bother about talking about that because there was an issue with another nitrification inhibitor in New Zealand, but just a bit bizarre, but it's all right. So we developed a new product, just at this one down the bottom here, to spray the urine patches with, which we've called Urine, standing for Optimised Recovery of Urine Nitrogen. And as I said, it contains a mixture of two products mainly. A urease inhibitor, that's the same thing I think in the United States and Canada is sold under the Agritain name. We use the same active ingredient. And that's in this country it's used mainly for treating urea and UAN to reduce ammonia volatilization. Because it's keeping the urine as urea for 5 to 10 days, it's allowing the urea in the patch to spread out laterally, and that's exactly what it does. So you're getting a far bigger pool of grass being able to access the nitrogen. And the gibberellic acid, which is widely used by farmers anyway, it works synergistically with the urease inhibitor MBBT by triggering cell expansion, elongation, sorry, that should be. So I'm not just saying that. Here's some results with one of New Zealand's top agricultural university, Massey University, and the little bars here, this is just two different trials, the one in autumn, one in winter, but this is urine, no urine, just the background grass, and you see you get this enormous increase in growth, and that, but with urine, but much bigger again if you're using Urine. So that's indicative of a massively increased recovery of the, or recycling of the urine nitrogen we are getting. The accent initially, the focus initially was on pasture production, but also on nitrous oxide greenhouse gas emission. And there's a graph showing the effect of with and with urine, with and without the Urine spray. The tall peak is this urine by itself, showing a peak of nitrous oxide emission in the first few days after deposition of the urine, and where that peak was halved with the use of the Urine. And this graph, the right-hand graph, is the same one but on a cumulative basis. But as I say down the bottom, we are now doing a lot of work on the measuring the nitrate leaching specifically. But that is preliminary results looking like that's quite good as well. I didn't intend to go through all that, but later this year we'll have commercial size spikies on selected dairy farms, and we'll be doing a lot of experimental government-backed research on those. Next year we'll be adding different things that you can do at the same time, such as fertiliser hop if you want to put a nitrogen fertiliser on at the same time as you're following the cows, as we say, or a plate meter to measure residual pasture measurement, or dung farrowing equipment that have been dragged behind, and also on moisture. So that's all going to be available next year. And then finally, I think this one takes a little while to load. Wasn't quite that slow, but. Okay, we've already developed this robot, or developed it from the one we bought in Canada, for people that don't want to do the towing job themselves. That can do it overnight, even though it's slow. It's got all night to do it. It can tow a small spiky quite easily. So that's all I've got to say. So thank you for listening.
Thank you, Bert. And do we have any questions?
Is it already a commercial product? Is it sold to farmers? Do they use it?
No, it's right at the stage of being commercialised. It's done all the preliminary testing, and so the commercial models are going on to selected farms this coming New Zealand spring, which is the fall over here, and it will be going to full commercial production in next year.
If I remember my chemistry correctly, doesn't urea itself leach? And if you are keeping it from converting, then, and so that it spreads laterally, isn't it also simultaneously going down?
Yes, that's true, but it is also being converted into ammonium quite rapidly as it's going down. So it's, I feel like it's a far lesser of two evils to keep it as urea for longer and to let it all go to nitrate very quickly. So, but it's quite right. And that's where MBBT is actually very good, because it keeps it as urea for a few days, but no longer than 10 days, where some say, so you're not increasing the risk of urea leaching right through the soil profile very much at all.